Hello everyone, welcome back to this Siemens SINAMICS S210 servo drive and motion control series video. And in the previous video, we create two TO technology object, and from this configuration, we linked with the drive and linked with the encoder. And then we download the CPU, and keep in mind, within this MC servo, there's one properties we need to take care is I factor this value. If we decrease this factor, then it will increase the workload from the communication, the perfect night IRT communication. And then we download the controller and we go to the commissioning, and we can use the access control panel, active, power on, so we can active and power on, so we can forward and backward jog move or do any control for the access using this control panel. Once you are able to use this control panel to move the servo motor, then the next things we can use the program to control this access. And in this video, we will discuss how can we use the program, the MC function block, to control this access. Okay, so let's go to the program now. So firstly, let's go offline. And before we start programming the function blocks, let me quickly review one video before I introduced this MC function block programming. If we go to the electrical automation hands-on and go to the playlist and find out this motion control. And then let's jump to the motion control playlist. And then we will see at this MS06G, this is number 7, S120, this is servo drive. I used this video to discuss how can we use the function block to control the S120. And in this video, I used this one big function block named the positioning access. This is my personal function block. Within this function block, it includes multiple instances. So it includes MC power, MC relative, and MC jog, and so on. But this programming style may be a little bit hard for the new learner. So in this video, while we are talking with this SINAMICS S210, I will use one traditional way, very simple way to program this function block, to program the MC function blocks. For the new learner, you can follow me step by step. If you know the TI portal already, then you can go to find this video and you can program one big function block by your own. So this big function block FB100 can be used as your personal template. In addition, I will also introduce a Siemens provide template function block. So that function block also connect with the HMI template. I will use another video introduce that template. So let's do step by step, especially for the new learner. You better program step by step by your own. Then starting from the easier style, then you can know more detailed after. Okay, let's go here. So let's firstly go offline and then go to the program blocks and click this add new block. I will firstly create one function and we can name this manual. So let's name function named 100. And this block we can call that FC underscore right drive MC motion control. Okay, and all of MC function blocks will be called at here. Then don't forget, go to the OB1. Let's firstly call this FC100. So to call this FC100, it's very easy, just drag and drag to here. Okay, so this FC100 doesn't include any input and output, will be only used as one bag. So in this bag, it includes everything, the function block. Okay, so now let's start programming the MC function blocks. So we can go to the technology, shrink this, go to the technology, and go to the motion control. The motion control all includes here, all those function blocks. So the first thing, this is the MC power, drag to here. When we drag here, and because this is the FC100 here, so here once we drag FB, the function block here, the system will pop up this message. So asking us to create one instant dB. Okay, we can create this instance DB. The IDB can be used as a prefix, and this instance DB is for the red motor. For the red from the 200, 201. Okay. Then we can create this function block called MC power, and it create this instant DB. And where is this instant DB? So it come to here. Go to the system block and go to here. And the reason why I rename and also assign a number manually, that's because after we create multiple access and each access have a multiple function blocks, then you will see it has bunch of function blocks at here without organizing the name and the number. So this area will show really mess. Even the system can still work properly, but the number is really mess. So personally, I like to assign a proper name and assign the proper number. Okay, we're starting from the 201 here. Then the access. So the access here, if this function block is to control the red motor, so we can drag this access under this TO, drag to here. Okay, so that means this FC power will be control this TO, this access. And then it need a command to here. Okay, so we can do this after. So let's leave all those commands to here temporarily without changing anything. Then let's do the next one. So we can firstly write this. This is for the red motor, MC power. Okay, after the power, then the common things we will do is reset. If there's any happen fault from this access, we need some way to reset the fault. So let's drag this MC reset. Select the single instant. Using the single instant is easier to operate for the new learner. Then select this menu, and we can start from the 202. And this is the IDB, instant DB, IDB underscore. And we can change this to red. Okay, click OK. Okay, this is the red motor and MC reset. Okay, and same thing, we will drag this red motor TO to this axis. And same thing, we will leave this command here. We will program this input output after. We can firstly prepare all the essential function block at first. Then after this reset, let's do the hot. Okay, the hot is used to trigger the access to stop. Okay, so we can program the MC hot. Especially once we trigger the speed control, the move velocity, then the access maybe keep going. So there's no any way to stop it unless you trigger hot or trigger stop. And keep in mind that the hot is used to trigger this command and stop the access. And after you trigger the hot, if there's another command to fire this motor to move, then the motor will move. The command of the pause is only used to temporarily pause the access. If there's one new command to move the access will move. So this is the key difference between the hot and the stop. The stop command can keep holding the access, but the hot is just a temporary pause the access. So now we can go to here, select the manual 203, and click this instant and IDB, red MC hot. Okay, and then we can drag this access. Okay, red MC hot. Okay, after the MC hot, then we can program the MC jog. So drag this MC move jog. Okay, and manually away, and the number 204 and IDB. Red. The red MC jog. Okay, and then assign this. So this function block is used to jogging forward and jogging backward. while the bool is on, the command is on, it's jogging. Once this command leaves this off, then the motor will stop. Okay? And after the stroke, the common way to fire the motor, the basically three main commands. One is move absolute, one is move relative, and one is a move velocity. So move velocity is doing the speed control. And for the positioning control, you can control the move absolute or move relative. Okay, let's do one by one. So for moving the speed, we can call this move velocity, drag to here. And this is the 205. And let's call this IDB, red. Okay, this is the red MC velocity. Okay, and we can drag this TO to here. That means this move velocity will control this red, this TO. And every time we trigger this command, then it will move with this speed set point. Okay, this move velocity. Then let's program the move relative. 206 and move relative and IDB. And IDB. And this is a red. Okay, and the red move relative. Okay, and drag this TO here. Okay, so every time we trigger this execute command, then the motor will run the distance command. Okay. And if this distance is the minus, then the drive will move backward every time. Every time you trigger, it will move the backward, travel this distance, just to move to the backward direction. Okay. After this relative, let's program the move absolute. So, okay, and here I can name this the 206, 207, okay, and IDB, and IDB, okay, and red. So as we can see here, because I have this prefix, so after we create all those instant DB here, it's very clear. We can immediately know all those rows are instant DB and all those instant DB are used for the red motor control. Okay. For each axis, you can use multiple move relative and multiple move absolute. Or every time you can change the command and then trigger. So they are doing the similar way. Okay. For the move absolute, so we can also drag this TO to here. Okay, and then name this as red underscore move absolute. Okay, then another very important command, that's the MC home. So this MC home can be used to set the encoder. Then we can drag this MC home to here. We can call IDB MC home red. So this time we can name that 210. Okay, MC home. And MC home, this mode is very important. Okay, let's drag this TO here. That means MC home will home this TO. And MC home is a little bit special. It has one mode here. So you better read the detail for the MC home, this mode number. So you can click the F1 and search the MC home, this mode. What does it mean of that? As we can see here, while the motor is doing the positioning access, the typical mode, we can use 0 that directly set the actual position. However, if you are using the absolute encoder, then your mode will be the mode 6 or mode 7. Usually I will use mode 7. Okay? And if you are using the incremental encoder, then you can use 0 or use 1. That depends on the more details on the mode. Okay, so the details are here. So while we are using the absolute encoder, like this case, I'm using SINAMICS S210, the absolute encoder, then the home, I need to use 6 or 7. The 7 is for the absolute directly side, and the 6, that's a relative side. So most of cases, we will use the 7. We can change the mode to 7, because in this case, I'm using absolute encoder. Okay, click Save. And let's write here, this is the red MC home. Okay, after this programming, we can have a quick review. So if we click this Close All Network, we'll see all those MC commands. They are very typical motion control commands. Even you are now using the Siemens motion controller or 1500 standard PLC to do the motion control, even other brands, they all basically following this style: power, reset, halt, stop, jog, home, move velocity, and move relative or move absolute positioning control. Okay, then we can program or connect the tag, connect the command to those function blocks. So you can imagine there need multiple variables need to connect to those function blocks. Then personally, I highly recommend you can create another DB. So let's create another DB, and all those commands can connect to that DB, the data block. So we can create a data block. Okay, so we can create a data block, and we can call this data block is named DB underscore write motor, control and status. Okay, and this DB number we can name that 20 or select the automatic. Okay, this is the drive write. Okay, DB. And from here, we can create the command. For example, let me firstly demonstrate one. So if we program MC power, so we can call that power enable, for example, and the name as a bool. Then we can drag this power enable. We define one bool, right? We can drag to here. So we can control this bool, and this bool come from this DB. And eventually you can imagine there are a bunch of tags at here. So we can organize all those tags and the status together. So each DB that represent the one drive. So this is very clear and very easy to organize. But there's one thing. So you need to manually create all those things. After we finish the red, then we move to the blue drive. Then you need to manually create those again or copy paste. Is there any efficient way or a little bit of professional way? So I like to show we can use the structure. So I can temporarily delete this, and we can use the structure. So we can use the PLC date type, and we can create a PLC tag. Here from this PLC type, I can rename this PLC tag as UDT underscore application access TO. Okay, and here we can create all the essential tags: bool, long rail, and status or word, all the status at here. Then for each access in this shared DB, so we can call the different UDT. Okay, so now I can manually create. For example, the first one, I can name that enable MC power, right? And this is the bool. And the second one, I can name execute MC reset, right? And then I can create all the rest of the commands and the status. Okay, then I can program all those essential commands and status. The typical status we can prepare at standstill, the move absolute done or move absolute busy, and MC error, that's the bool, and the actual speed, velocity, and the position. Okay, after we finish this UDT, this structure, then we can close it. And then go back to this DB. So in this DB, it can include a red drive, blue drive, or any other drives. And each drive, we can create one main tag here. So this is based on the structure. So we can call that structure st underscore write drive. And the date type, this time, we need to call the date type. And if we go down, the date type name is UDT app access. So we can copy this and paste to here the date type. Call this UDT. Okay, double click. Then we can see the system will automatically create this instant, those variables. Okay, and for the blue drive, I can call the ST blue. So call this structure, then the blue, all the variables can be created using this structure. Okay, and in case one day you think, now I need to add one variable. For example, I need add one variable that named the status underscore MC move relative. Done. For example, add one tag. Once we add here, we will see, go back to this DB here. Here, because it got an update, it's showing red, tell you, okay, somehow here it got a change. So don't worry, even that show red. You just need to compile or you manually select them, click and click this update. Okay, then it got update. Then when we expand here, we will see this move relative done. That instant got added here. Okay, and the rest of them, no any changes. Okay, don't worry, gotta screw up the before or after those tags. Okay, now we can close this. We create these variables in this DB, and based on this structure red, then we can float this window, go here, and we can drag those essential commands to the function blocks. So for the MC power, so we can drag this MC power to here, this enable. Okay. And let's go down for the reset, the execute reset command. Okay, reset. Okay, and MC hot, so MC hot command, MC hot. Okay, and MC jog, so jog we need to move forward and move backward. So execute MC jog forward, and jog backward. Okay, and this velocity we can set a solid value. After all, the jog usually can be set as a solid value. You can set a menu button jog forward, jog backward for the operator on each line, right? So here I can set 360, 1 revolution per second. So this is a jog move. Okay, then let's go to the move velocity. So move velocity, firstly we need a move velocity trigger signal, MC move velocity bool. Execute. And then we also need the velocity command. So this command, let's leave the mouse here. That means this is a long rail. So we need the set point long rail velocity, long rail. Okay, we can drag to here. And here we will see it has acceleration, deceleration, and jerk. Default, all those values shows -1. The -1 here in Siemens, that means the system will use the default acceleration, deceleration, and jerk. So if you recall in the previous video I introduced, when we created the TO, so all those default acceleration, deceleration, all set, initially set in this TO already. If we double click the configuration, and if we go to the dynamics default values, so as long as the acceleration, deceleration, and the velocity set at -1, then the system will use all those default value. Okay, even you forget set those acceleration, deceleration, don't worry, the system will automatically pick the default value. Okay, for the -1 here. Okay, and for the velocity, you can control the direction 0 or 1, or you can set the velocity positive or negative. So they are working the same way. Okay, so this is the same way as setting this direction. Okay, this is the move velocity. And then let's go to the relative. So we have this relative, this distance. So we can drag this distance long rail here. And also we need this move relative command to here. Okay, and then let's go to the move absolute. move absolute, the same thing, move absolute jog command. Same thing, move absolute this trigger command. And the position, we can, this position set point, this move absolute position command. Okay, so then the last thing is the MC home. The home, the command can come from the execute MC home. Okay, drag to here. And when we trigger this MC home, so what the real value we need to set to the access. So we can set a value. For example, in this case, I can prepare 100 at here. So every time we trigger, then we will see the access actual position will show 100. Okay, so we can save. Then we will see I prepare the status here. Let's also connect some important status. For example, for the move absolute, we can connect the move absolute done signal and the busy signal. And the reason why I prepare this done and the busy, that's because for most of cases, the move absolute is very important to control the tool moving back and forth or to apply something on your parts. So probably you could have a multiple move absolute, the function block call with a different instant, or using one absolute function block. Every time you can change the position and the trigger. Prepare first and then trigger. So every time when you move to the next command, you can waiting for the done signal and also waiting for this busy signal. Then you can prepare the next position and trigger the next position. Okay, so you can imagine there could be a sequence control. So you prepare the step 1, trigger step 1, wait for the step 1 done. Then you prepare the step 2 position command, trigger step 2, and wait for the done. Then prepare the step 3 position. So this is a basically sequence control using one function block call. Okay. Another thing is the arrow. So usually the arrow, the status come from the MC power, can connect to the arrow. This is the bool. So we can monitor if the access has an arrow. If you want to look at the arrow ID, so the arrow ID, this is a word output. So we can create one word status to read the code from this MC power. Then we will see I prepared the actual velocity and the actual position. So how can we read the actual velocity and the actual position? Okay, if we scroll down at the bottom line, we can create the actual, this is the red, actual velocity and the actual position. We can copy the velocity and the position, copy them out to this actual position and the actual velocity. Basic command and use the move. Move. The source comes from the axis. We can double click and paste here, click the dot. Then we can scroll down, find the actual speed or actual velocity and the actual position. For instance, I can pick this actual velocity. And then from the right side, we can drag this actual velocity to here. Okay. And we can drag another move. Same thing, copy this axis, this dB10 to here. Click dot. And we can pick the actual position. Okay. Actual position. And move target to the long rail actual position from the dB20 here. Okay, dB20 here. Okay, so using this way, we can copy the velocity and the position out, so we can monitor this access status. All right, those are the very basic and typical function blocks. So we have the MC power, reset, home, hot, and forward, backward, jog move, and the positioning move, and the velocity move. Okay, so now we can do a quick test. Now, again, all those function blocks are called by this FC100. From this OB1, this main block, we need to call this FC100, drag this FC100 to here. Then all those function blocks will be called. Okay, now we can download, save the project, compile, see if there's any wrong, and we can download. So while this download, the system do not need to be stopped. So we can monitor the controller. So now the controller is showing green that is running. So I can click this download. Because those all the programming wise. So download. Okay, now let's double click, jump into this FC, and let's click this monitor. So power is important. So once I turn on this spool to true to enable this access, then this entire drive, this access will be powered up. Okay, so we can enable. So I can hear a little bit noise from the drive, and in the meantime we can see the status true, busy true, no error. So now this access got a power up. Okay, if you have any error, maybe the error come from the safety or come from some other status. So you can try to execute to trigger this execute to reset the error. Okay, power reset. Now we can do a very simple test. Let's use the move jog. So the command is 360, 1 revolution per second. Now I can turn on this jog move. Let's go forward jog. So as we can see, this red drive can move forward. And if I release this spool, okay, it stopped. Turn on this backward, true. Okay, it's moving backward. Okay, and while it's jogging, so we will see this busy turning on. And in position, in velocity, showing true. Okay. And now let's go to the move velocity. So move velocity, this command is a trigger command. So once we set the speed and once we trigger, we will see even the execute turn off, the drive still traveling. So now let me set a command. So I can set 720. Okay, a little bit faster. 2 revolutions per second. Prepare, and then let's trigger. Trigger. And now this motor is traveling. So if I turn off this command, we'll see. So the drive still keep going. How to stop the drive? So we need to trigger the hot, MC hot. Or any emergency, you can leave this MC power off. Then the drive will turn off. Okay, I can trigger the MC hot. MC hot, this command, trigger, boom, the drive will stop. This is ramp down stop. And the deceleration, you can control this deceleration. Usually we can stop gently and slow down. If there's any emergency stop is needed, then you can even turn off the MC power. When this MC power turn off, this is a similar idea as the emergency stop or MC stop command to hold the drive. Okay, so we can do a quick try. So let's go to the MC velocity. So this time I can fire a negative move. Okay, move. So let's set 720. Okay, then I can trigger. So we'll see a moving backward. And now if I leave the MC power off, this is kind of like an emergency stop. Okay, let's turn off. Boom, the drive will stop. Okay, and then we try the MC velocity. So now let's try the MC position. So I can shrink this MC velocity and we can try the MC relative. And before I try this move relative, I can set the encoder first. So for example, now the position, that is this value. So I can set 100 first. Now let me trigger this MC home. So this is my target and mode 7 because I'm using the absolute encoder. So now I can set, but set 100. Okay, set 100. Okay, now let's trigger the MC move relative. Okay, move relative, and the velocity we can set a value. Okay, here I need to set a velocity value. Sorry, forget this. So I can disable. I can set a velocity. For example, we can travel very slow. 360. Okay, and distance we can set it. So we can solve this velocity. And now let me download. Download doesn't matter. So this download do not need to stop the CPU. And after download, let's click this go online. So here all show green, then matching with. So that means online, offline, they matching. Okay. So we are setting this 360 velocity, and the distance I can set. Every time we trigger, it will travel 1000 distance. Okay. So now I will trigger. Currently, our drive position, that's the 100. After I trigger this move relative, the next time when we monitor here, it should be the 1100. So I can shrink this MC home first. So now, let me trigger this move relative. Okay, trigger. Okay, it automatically stops at this 1100. If I trigger again, it will move to the 2100. Okay, trigger the third time, it will move to the 3100. Okay, 3100. Okay, so moving backward, we can set this distance to negative. For example, let's move negative 1000. Negative 1000. So we can trigger. Okay, so we will see this command, that's the trigger signal. Once the drive get here, it will not keep triggering. Okay, so it only waiting for the rising edge. Okay, so it get this 21 again. So let's trigger again. Then next time it should get 1100. Okay, 1100. Okay, let's trigger again, go back to the 100, backward. Okay, this is the move relative. Move relative, it doesn't care where it was. It only care how long, what the distance you want to travel. Travel to the positive or travel to the negative. Okay, then the more common used positioning control command, this is the move absolute. Okay, so we can also monitor the velocity and the position. We can prepare the velocity first. I'm gonna prepare this velocity. So velocity I can prepare, let's do faster, 720. Okay, and download. Monitor. So while we are triggering this move absolute, so we can monitor this velocity and also monitor the position. So we can give a target. The target we can set to 2000. Okay, because the speed is faster. So now I will trigger. 720. Moving very fast, and the position it travel at 2000. Okay, so now I'm gonna travel to 5000. Trigger again. Every time it only need the rising edge. So rising edge, trigger, move, 720. Okay, and in the meantime, let's watch this done signal and the busy signal. Okay, so turn off first. So once the command turn off, the done turn off. Okay, and let's move to the 0. Then let's trigger. Okay, while it's traveling, the busy will show true. And once it's got that position, then done signal will turn on. Busy will turn off. Look at this timing. Okay, let's change it again. 5,000. So while I'm turned off, then the done signal turn off. So now I'm gonna travel again. Trigger. Okay, while it's moving, busy is on. Once it's get to 5,000, then the done signal will turn on. Busy will turn off. A done signal, when the done signal will be turned off, so the execute we can. Once this execute turn off, then this command turn off. Okay, so this is move absolute. Okay, and now for the MC home, if I set this position, set this position, set to a 100 here, and because we are using the absolute encoder, now if I cycle power, after a cycle power, let's see the actual position value. Okay, now I'm going to cycle power this drive. Okay, now I cycle power this server drive. Okay, the system power up and I can go online, monitor, and click this monitor. So as we can see here, because this motor doesn't have the brake, it slightly got off, but we will see this value 99.9 still here is now reset to 0. So this absolute encoder can save this value. Okay, so if now I travel to a position, so if I travel to 2,000, or let's travel to a further, so 10,000 trigger. Okay, oh, sorry, I forgot the power up. So if we forget power up the access, once I trigger, then it will show the arrow. Okay, that's because after the cycle power, I haven't power up the access yet. So let me move up. So turn on this MC power. Turn on MC power. Okay, MC power up. Then go down here. So currently it at 99.9. And let's trigger this move absolute. Trigger. And in the meantime, let's watch this position and speed. Okay, now it moved to the 10,000 this position. Okay, then I will cycle power again. And while it power down, I will slightly move this encoder. And let's see if this encoder can record the offline moved while it is powered down. Okay, so this time I will power down again. Then for this right drive, I will slightly move, basically move 90 degrees. Okay, and then I will power up. And let's see if this absolute encoder can record this move while it is powered down. Okay, the system power up. Then let's go online and click this monitor. Click this monitor. Okay, we will see basically it got to move 93 degree. So because I'm moving backward, so it goes slightly lower than the 10,000. Okay, that means during the power down, if we move this tool, so this absolute encoder can record this position. Okay, this is the way to operate the absolute encoder. So keep in mind, doing the MC home, we have to use 6 or 7 while we are using the absolute encoder. And typically from the SINAMICS S210, all the encoder we will use the absolute encoder. So keep in mind, don't leave the 0 for this MC home. Otherwise, once you trigger the home, every time you find lose power, the access is always the 0. That's because we are now using the 7 or 6, the MC home mode. Okay, keep in mind this. Okay, this absolute encoder can record this. Alright, those are the commands to control a positioning access. The typical command: power, reset, hot, jog, move velocity, move relative, and move absolute. And don't forget, for the absolute encoder, we will use the mode 7 or mode 6 for the MC home. In the meantime, we can monitor the actual velocity and actual position. Okay, this is using the motion command to control the axis. Again, based on the commissioning control panel, this axis control panel, once you are able to use this panel to move your axis, then the next things you can use all those typical and essential motion control function block to control your axis, control your drive. So you can leave this FC100 as your personal template, or as I showed in the SINAMICS S120 that video, you can program here as one big function block. So all those individual FB motion control function block can be used as the multiple instance. So using a big function block FB, or using the Siemens template, or using the way shown in this video, a FC call multiple MC function block. Either way, as long as you can make the system work, this is a good method. Okay, this is using the function block to control this axis. Okay, we can use the similar way to program this blue. The only difference is we can drag this TO to here, to this axis. And then all those commands and status we can call from this DB. And we will use the ST blue. So all those commands will replaced by the ST red to ST blue. Okay, so all those here can be used as a template. Then we can create another FC and replace all those commands. Alright, this is the motion control command. Thank you for watching. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.